User-managed backup and recovery. Well, thus far in the course, if you've been watching the nuggets sequentially, we've worked quite a bit with RMAN, and in particular, you should know how to use that tool to perform various types of backups in Oracle 11g. In this nugget, we're going to look at the other side of the coin. As opposed to RMAN server backups, we're going to learn how to use operating system and SQL Plus commands to manage backups ourselves in a user-managed fashion. Now, some take-home lessons that I want you to take from this particular nugget are that although user-managed backups are supported by Oracle, you're going to find that there's quite a bit more tedium involved in this backup and recovery type than there is with RMAN. As a matter of fact, that'll become very clear to you in the next nugget when we look at restoring database objects using RMAN utility. So specifically, we're going to learn the mechanics of user-managed recovery. There's quite a bit of vocabulary that's new that we have to get down. And then in the lab or demo portion of this nugget, we're going to simulate various failures and do complete and incomplete database backups and recoveries. Recoveries from the entire database being corrupted, missing, damaged, whatever, and specific scenarios, various losses. What happens if you lose one copy of your control file? What happens if you lose all copies of your multiplexed control file? What if you lose one or more archived redo logs? What's going to happen then? Well, you'll have answers to those questions by the end of this nugget. So this is some extremely valuable skills that we're developing, not only for your success on the OCP certification exam, because you'll certainly be confronted with these various and sundry scenarios, but also in your real-life work as an Oracle database administrator. Let's get to work. Now then, officially speaking, a user-managed backup is backup and recovery in Oracle 11g without the use of the RMAN, or the Recovery Manager tool. S, by the way, is medical shorthand. C with a bar over it is medical shorthand for with. S is medical shorthand for without. I come from a long line of medical personnel, primarily nurses. My twin sister's been a nurse for about as long as I can remember, so sometimes medical shorthand will creep into my nuggets just by default, and I apologize if that creates any undue confusion. So as I said at the opening slide of this nugget, Oracle does support user-managed backups, so these are skills that we need for our exam and possibly in our real-life work. User-managed backups involve the use of SQL Plus, as well as various operating system commands. Like in the Windows world, we may use copy or xcopy. In Linux, Mac OS X, we'll probably use the cp command. Obviously, we can also use graphical utilities, the GNOME desktop in Linux, for instance, the Mac OS X Finder, or Windows Server 2008 has the Explorer shell. We can drag and drop to copy files that way as well. It's all good. It depends upon our comfortability. Now, especially when we deal with online or hot backups, which are backups in which the Oracle database is open and available for connections, you may run into problems doing drag and drop copies using graphical utilities or even using command line copy commands. Oracle gives us the ocopy command line tool, at least in Windows, that allows us not only to back up hot files that are currently open in use, but we can also copy files to and from raw disk partitions. And we'll remember from the beginning of this nugget, we use raw or so-called uncooked disks when we use ASM and use disk groups. Alright, so that's the technology involved. The other side of the backup and recovery equation is the server-managed backup, and that in Oracle vocabulary simply means that we're using Recovery Manager. And as I said, again, to repeat, we now know how to use RMAN to do various backups, and it really can't be any simpler, especially if you're using the fast recovery area. A little bit more to it with user-managed backups. In point of fact, I want to make the statement right now, just as far as a real-world best practice, that you really need to do user-managed backups using shell scripts, using operating system scripts. You definitely do not want to be running user-managed backups from an interactive terminal prompt session. Reasons for this? Well, the number one is a lack of consistency. Number two would be the possibility of human error. You know as well as I do in Oracle or even at the operating system command line, one missing character results in your script doing things that you may not have anticipated. Especially with something as important as a database backup routine, you want to make sure that your syntax is pristine and that you can repeat that syntax as many times as you need to over days, weeks, months, and years. So although how in the lab that we're going into in this nugget and the demos that I'm going to show you will be working from an interactive command prompt, you'll want to do that in your development environment for sure. But ultimately, the deliverable for your user-managed backups in Oracle database are going to be a series of operating system shell scripts that you can then schedule to run on a regular basis. All right, that disclaimer having been made, let's get more into the mechanics, the hows and whys of user-managed backups. On the backup side, note that we can do both cold and hot backups using user-managed technologies. The offline backup is also called a consistent backup, you'll remember, whereas the hot or online backup is called inconsistent. Now, what's the difference? Just to review, when you shut down a database, in particular, you use the shutdown normal or shutdown immediate or shutdown transactional, we can rest assured that any outstanding redo information, any outstanding transactions that need to be committed permanently to the data files have been committed, and any transactions that need to be rolled back or just are not relevant will be rolled back. So the database will be in a consistent state, and in that environment, shutting down the database gracefully, backing up your data files, your control file, your archived redo log files will result in a clean restore on the other side, in particular a complete restore where you can restore the files but not have to undergo the media recovery process. Remember the difference between restoration and recovery. Restoration is where you replace one or more files from a known good backup. Media recovery is handled internally by Oracle, and there it's using your redo log stream in order to bring back any transactions that haven't been recorded to the data file but that do exist in that redo log stream. If you're in no archive log mode, if you're not archiving your redo log files, you really don't have much of a choice. You have to do a cold or offline backup. As long as you're running an archive log mode, we can actually do user-managed backups in a hot database environment. There's a separate procedure for that we'll learn about in just a minute. It's called putting your table spaces in what's called backup mode. You can actually put your entire database in backup mode. That effectively freezes the affected data files that allow you to take a backup of them and perform complete recovery, again, as long as you're backing up not only the data files, but your redo log files. Now, on the recovery side of things, this is an important bit of terminology distinction for you. Restores can be either complete or incomplete. Typically, if you have some catastrophic failure, you're going to recover your database to the point of failure. In other words, give me back every committed transaction you possibly can. You want to bring the database as up to date as humanly possible. That's the normal way to do a recovery, or a restoration recovery, I should say. Now, what is incomplete and why would you want to do that? Incomplete recoveries are also known in Oracle terminology as point-in-time recoveries. This is where you can specify an endpoint. Let's say you had a failure at 2 p.m., but you don't want to do a complete recovery right up to that point of failure. Maybe you can't do a recovery right to the point of failure because you're missing the most recent redo log file. That might have been part of your problem to begin with. In that case, you can do an incomplete recovery in which you bring your redo stream back up to a particular time and date, and then any transactions between that endpoint and the point of failure would be lost, hence the term incomplete. But like I said, there may be cases, though there probably will be in your lifetime as a DBA, to where you're forced to do an incomplete recovery, or in some cases you may just want to, out of hand, kind of roll back your database to a particular date and timestamp. More on that later. Now, specifically, what are those procedures for running a user-managed backup in Oracle 11g? Well, here's the deal. Depending upon whether the database is open or closed, the path is going to be a little bit different. Remember that in no archive log mode, a complete backup with the database closed or shut down is our only option. First thing we're going to want to do is make sure we have our file paths for the database assets we want to back up. And those database assets are going to be, obviously, all of your data files, your control files, and your archived redo log files. Now you'll see in the lower right, I have a parenthetical note that says no need to back up temp objects. You'll see in your exam objectives that you need to know how to back up temp files and the password file. Generally speaking, you don't need to back up temp objects. It's 99% of the time best practice just to drop and recreate them if you have a problem. Similarly, password files are rarely needed to back up. You can consult the Oracle documentation for more backup on that statement. Now, coming back to our regularly scheduled programming, how do we get the locations of our data files, control files, and archived redo log files? Well, if we're in SQL+, we can query our dynamic performance views, various $, views. We can query some of our DBA views, or if we're more graphically inclined, as you remember, we can fire up the Oracle Enterprise Manager web application and check those paths out. Now, next step is going to be dependent upon whether we're doing closed or open backups. If we're doing closed, we're going to do a shutdown. We're not going to do a shutdown abort. We want to do a shutdown normal to make sure we have consistency, right? Once and only once that completes, we can then use our operating system commands to do file copies, just simple source and destination copies of those files. Remember, this is user-managed backup after all. Once those files have been copied off, we can issue the startup command, bring the database online, and you're done. Now, it kind of goes without saying, but here I am saying it, that when you run a closed user-managed backup, the database is going to be completely inaccessible for the duration of this process, okay? Now, on the other hand, if we're going to do a hot backup with user-managed procedures, we're going to take each table space, not offline, but in a special mode called backup mode. And then while the table space is in backup mode, we'll dip into, after we discover which data files are associated with a given table space, we'll copy off those files, and then we'll put the table space online. That's the kinder, gentler way to do a hot user-managed backup, because the idea is we're not downing the entire database. As a matter of fact, backup mode does not down anything. You can still read and write to those data files as you're copying them, which is kind of cool. And there's some mojo magic happening in the background where Oracle backs up any change vectors in your redo stream and kind of freezes the file headers on those data files that are in the offline, I keep using offline, in the backup mode table space. Now, you can take an entire database and put it in backup mode, but you better have a lot of disk space because, like I said, for the duration that the object is in backup mode, you may have users running updates, running deletes against those data files, and Oracle needs to track all of those change vectors somewhere, now doesn't it? It needs to also involve undo segments because, for instance, if we're going to do an update, we have the previous data as well as the updated data to manage as well. So that can become pretty significant, not only from a disk space utilization point of view, but also just in terms of raw CPU and memory power. I often say in my training courses and in industry, telling my employees, colleagues, heck, I'll even tell my boss, that a good Oracle database backup is only as good as its ability to be successfully restored. So to that end, we have 2 points of view. We have one, performing regular trial restores to make sure that our backups actually work, and number 2, running file verification on our backed up files to ensure that they haven't been damaged in that copy process. To that end, I want you to be aware of an Oracle inbox utility that comes with the Oracle 11G binaries called DB Verify, and its functionality is similar to MD5 summers if you've used those. I do a lot of software development during my day job, and we use MD5 quite a bit when we're having people test software because, for instance, we can post an image of our software to our FTP site along with the MD5 sum that we have for that file. And then when our tester downloads that binary and runs MD5 on their end, ideally we want an exact match between those sums to make sure that not one bit of that file has been corrupted or changed in transit. Same idea with DB Verify. We can do file verification. We can actually verify individual segments. You'll remember that a segment is a part of a data file that represents a single Oracle object, for instance, a table or an index. And we can do that on offline and online files. It's a really good tool to be aware of, and it's instantiated in the file system in the executable command dbv. We're going to learn how to use this in our upcoming demo in point of fact. Speaking of which, it's time for our first demo. Here we're going to cover backup technologies. I'm going to teach you how to back up the control file. We can do that a couple different ways. We can back it up in a binary format, which is what we'll want to use for recovery. We can also back up the control file to trace, which gives us a human-readable text file. That can be useful for analyzing the contents of that control file. We'll then run some database backups in a couple scenarios. We'll do both the cold backup with the database shut down gracefully. And I'll also show you how to work with backup mode and doing online user-managed backups. Finally, we'll do a quick run of DB Verify or the DBV tool to make sure that our backed up data files are in fact complete and undamaged. Welcome to our first demonstration. Here we're going to do some work on user-managed backup in Oracle Database 11g. To review what we've got going on this Windows system, I have my C drive as my operating system drive. D is my Oracle drive that has my Oracle base and Oracle home hierarchy. And then I have a third disk called data on which we're going to put our backup sets, our backup destinations. And I've created a couple folders here, one called UM1 and another called UM2 to denote user managed 1 and 2 respectively. And what we're going to do is just go item by item the elements that we need to back up in a user managed scenario. To begin with, you'll see that I've already logged into SQL Plus as the sys user with a sysdba privilege, and I've run select name from $data file to give me a quick run of the locations of each of my data files. Now we may need to hit up another view to learn the table spaces in which each of these data files lives. We'll get to that in just a moment. The first element I want to back up is the server parameter file, and the easiest way to do that is to use the create p file from sp file statement. If you followed my training for CBT Nuggets with the DBA1 skill set, then you're already familiar with that. Now if you want to specify a location for the p file, that's very easily done. So let's do from our SQL Plus prompt create p file, and I'm going to pass in a path using single ticks to denote that path, eum1, and I'll just call this backup_init.ora. Enter to give me a new line from sp file, and I'm just going to use the system's current sp file location by not giving any other parameters. File created, and we can verify that by moseying on over to our E drive into our UM1 folder, and there we see, very tiny file indeed. Next, why don't we make a backup of our control file. You'll recall that we can make a binary backup that's useful for recovery operations. We can also back up to trace. We can do this with alter database, backup control file, to, and then you specify your path. UM1, I'll call this cf.bin to denote that it's a binary file. I'm going to up arrow to bring back my buffer, and I'm just going to edit this command a little bit. Backup control file to trace as, and I'm going to change the name of the file here. We'll call it controlfile.txt to denote that this is a human readable text file. Again, let's come up to our UM1 folder and verify that our binary file is there as well as our text file. And I'll open that up, and sure enough, in human readable format, we can see the contents of our control file. Exactly what we would expect. So far, so good. Let's move on to whole database backup now. We'll start with the consistent whole database backup, which assumes that we're going to bring down the database. Now, of course, step one is always to figure out where your files are. We can use $views in SQL Plus, or we can log into Oracle Enterprise Manager. I think you should be familiar with both of those. On the server tab in particular, under storage, we can get our control file locations, our table spaces. Actually, let me click table spaces just to get a run. These are just the default ones, because in just a moment when we do inconsistent or hot backups, we're going to need to take a table space into backup mode, so we should review these names. So it looks like users is the default name of the users table space that has one data file in it in that location. So we'll have to note that. We'll also want to make a note of the location of our archived redo logs. We do not need to back up our online redo logs. That comes directly from Oracle, but we definitely should back up the archive logs. We know that we can back up archive logs so easily using RMAN. It's going to be a little bit more work here. We can get the paths from Oracle Enterprise Manager Server tab archive logs. We'll click that now, and you can see that right now I'm storing my archive logs in my flash recovery area on my D drive. I might want to consider changing that actually, because we certainly don't want to keep our backup files in the Oracle base location. And we'll switch on over to our SQL Plus session, and we're going to shut down the database cleanly. We're not going to do a shutdown abort. We're going to do just a plain old garden variety shutdown, and if we don't specify a tag to shut down or a parameter, it will assume normal. Now remember, we can do the whole database backup backup in this consistent fashion, regardless of whether we're in archive log or no archive log mode. After we finish this process, though, when we do a hot backup of data files, remember that we'll need to be working in archive log mode to make that happen. Now that the database is shut down, we're free to just do a manual copy. Again, we can use a command line tool, CP in Oracle or Mac OS X, copy, Xcopy, or Oracle's own OCopy from the command line, or we can just use graphical techniques like I'm going to do here. I'm in the Oradata ORCL subfolder where my DBF files are located, so I'm just going to select those DBF files, not the temp file, but I'll grab the other ones, and I'm going to put them into a subfolder of UM1. I'll call this consistent whole DB. We'll go into that location, and I'm just going to right drag with my mouse and select copy here from the shortcut menu to bring those files over. Again, it's completely inconsequential whether we're using GUI or command line tools here, especially because the database is offline and closed. Alrighty then, we'll want to do the same thing with the archived redo log files. I happen to have that folder open on my system, and we have a folder created for each date that the database has been online. Looks like we have some content in this first folder. We'll drag those over and add them to our backup set. Sweet. So at this point we have the major elements. We have the control file, the server parameter file, our data files, and our archived redo log files. That's pretty good as far as I'm concerned. We'll come back to SQL Plus and issue startup to start the database. And I'm kind of pushing things along a little bit harder by using startup force, but the bottom line is we're now back online and everything's hunky-dory. Now, with an online hot database, we can use the so-called backup mode to, in a sense, freeze the data files within a specific table space. Now let me show you how that works. Let's assume that we want to back up the user's data file, and we know because a few minutes ago through Oracle Enterprise Manager we verified that that data file is contained within a table space called users. Now here's what we want to do. We're going to do an alter table space, the name of the table space, begin backup. So users can continue to access that data file and even make changes while the system change number is also being frozen in time for our backup purposes. At this point, we're now free. We're free to copy that file. I'm actually going to do that from the command line here. Why don't I hit host to hit a command prompt environment, and if you run ocopy with no parameters, you'll get some syntax help with it. Remember, ocopy is especially cool because we can copy files that are actually open and hot, and ocopy also recognizes raw disk partitions that are used with ASM disk group. So ocopy is a particularly cool command. Now I used the cd command to mosey on over to the location of the source data files in my Oracle home, or Oracle base directory actually. So I'm going to do a dir star.dbf to show me only those files, and there's my user1 file. So I can very easily do an ocopy of users. I just typed USE and hit tab to do tab completion. You Unix Linux users have been familiar with that shortcut for a long time. Space, and then the name of the destination path, like so. So basically it's ocopy, source file path, space, destination file path, and that's all there is to it. Now what we'll want to do is exit out of host mode and get back into SQL Plus, and I'm now going to up arrow to bring back my begin backup statement, arrow back with my left arrow, and unfreeze the table space. Don't forget this step, friends, by running end backup. So that's what we would do successively for each data file that we want to back up. I think you see now my suggestion earlier to automate all of this with a well-crafted shell script is good advice, because you certainly don't want to be horsing around with these commands iteratively and manually. That's ridiculous. So here's our user1bk.dbf file. You're probably wondering, how can we rest assured that this file is consistent? In other words, that it's not damaged. Well, there we'll want to use the dbverify command, also known as dbv. So what I'm going to do is exit out of SQL Plus, and we'll mosey on over to E, and there's our file. I just like to be in the directory as the target file. DBV is the name of DB Verify. The reason why I'm able to launch these commands from my ePrompt instead of Oracle Home Bin is because, of course, I have Oracle Home Bin in my search path. That's an important thing that you should always have active on your Oracle systems. And to run this command is extremely easy. We just do DBV and then file equals and then the name of the file. Again, I'm using tab complete here. And then optionally we can do feedback. I'm going to do feedback equals 100. And what that parameter will do is for every 100 pages in the file, it'll give a dot. So just count the dots to determine how many pages are there. Note that it gives you the highest system change number contained in that file. Tells you how many pages have been examined, how many have failures. Fortunately, we're 0 there. How many are marked corrupted. So this is just basically a quick way. You want to see zeros for those bad values, and you may also need to note the system change number as well. The flip side of user-managed backup in Oracle Database 11g is user-managed recovery. And I think that this table that comes to us courtesy of the Oracle Database Backup and Recovery User's Guide sums up the basic procedures for user-managed recovery in such a wonderful way. I figured we would work directly off the table together. Now, the first distinction we need to make is something I've already alluded to several times in the training, and that is when we do recovery, when, heaven forbid, we have some maybe user error, a user inadvertently drops a table, or we have some media failure perhaps that results in a data file or multiple data files just going offline completely. There's so many different ways that our database could require recovery. We have the distinction between restoration and recovery proper. And restoration, as I've said before, is where we take the files that we've so carefully backed up from, say, the previous night or whenever, and we restore them to either their original location, overwriting the source files, or what some administrators do will actually restore the backups to an alternate location, which can be fine as long as we let Oracle know about those new paths. That's particularly important when we're restoring control files. We'll do that in the upcoming demonstration. So that's restoration. Media recovery happens when we issue the recover SQL plus command, and this is an important command to have in your tool belt. Recovery can be automatic or manual. It's best to do automatic recovery because you don't have to specify the redo log file names to be applied to the database. Oracle just goes and fetches them as it needs them to roll forward the redo data and recommit transactions that should be permanently committed. Yet another distinction in our vocabulary is whether the file to be restored and recovered is a critical or non-critical file. And this first row in the table deals with a critical file loss, and the second row deals with a non-critical. Basically, Oracle considers a critical file to be one where if you don't have it for any reason, the database needs to go down. Just do not pass go, do not collect $200. You are shutting down, and Oracle will in fact shut down the database. So examples of critical data files are either A, any data file that's located in the system table space, and that should make sense right off the bat why system data files are crucial or critical to the database's operation. Also considered critical files are any data files that have active undo segments. Now what does that mean? That means that we actually have one or more user sessions who are modifying or attempting to modify data in a data file, and we have the previous information stored in undo segments in the undo table space. And as I said, because those are considered critical data files that could result in permanent data loss, Oracle will bring down the database. And then I'm just going to go through here and we'll read this together. If the hardware problem is temporary, we can just fix it and restart the database and let automatic crash recovery recover any lost transactions. But if the problem is permanent, it was a hardware failure and the disks are just scratched and we need to replace them, for instance, then we'll restore the data files from backups and then perform a closed database recovery. Basically, we're going to put the database in mount mode. We're going to start the instance, mount the database, but don't open it, run the recovery command manually, and then start up the database. Or should I say then open the database. For non-critical file losses, data files that are not in the system table space or data files that are not not actively involved in undo, that don't actually have volatile changes happening right now or at the time of the failure, we can keep the database open, but we can simply take individual data files offline and basically swap them out. If the unaffected portions of the database must remain available, then do not shut down the database. We can keep the database up and open. Take table spaces containing problematic data files offline using the temporary option, then use this procedure, which we'll look at again in the upcoming demo. So again, we do not have to shut down the database as long as the file loss wasn't critical to the database's operation. Now you might be thinking, well, what about the control file? That's covered in the next two scenarios. The two scenarios are you've lost one copy of a multiplexed control file or you've lost everything. Well, I hope that this would never happen to you, but it's a possibility. If you lose all your control files, we have no other choice but to either restore a backup and then open the database with the reset logs option. And reset logs, remember we dealt with incarnations, database incarnations in an earlier nugget when we talked about virtual private catalogs. When we open a database with reset logs, essentially it sets the database to just a new path, basically. All of your system change number incrementation and all that gets reset, and you're starting completely fresh with a new incarnation of the database. If we do not have a backup of the control file, which I hope would, again, not be our situation, we can attempt to recreate the control file. That is an absolute last-ditch effort, though. Now, if we lose just one of many control files, that's still a problem, but it's much easier to fix. Copy an intact control file copy into the location of the damaged or missing one. If we cannot do that for whatever reason, then we can restore a good copy of the control file to an alternate location and just simply set the appropriate initialization parameter file to reflect the new location of the previously damaged control file, and then open the database. So it assumes, and it's true, you'll see this in the demo, that the database will not open unless all multiplexed control file copies are online, and that's true. As far as the archived redo logs, if you're missing one or more of those, then Oracle tells us we must restore backups of the archive logs for recovery to proceed. Basically, our only choice in this situation is to perform incomplete recovery. Basically, we're recovering the database until a particular SCN or a particular file. I gave you this example a little bit earlier in this nugget, where you have a failure point and your ideal is to restore the database all the way up to the failure point. But if you're missing one or more redo log files for whatever reason, maybe a backup failed or maybe you just didn't have a backup of those, then we have no other choice than to perform incomplete recovery and stop before our first missing redo log file, and then just basically write off any delta or change that occurred between then and when the failure occurred. That again is a worst case scenario. Finally, we have the file that contains all of our initialization parameters, known as the server parameter file or SP file. We can back those up very, very easily, and if we have a backup, which I would trust that we're doing, we know that RMAN, for instance, will back up the SP file and the control file very easily with a single configure command. We're going to have to use our operating system script files, though, to do this or to automate this in a user-managed recovery context, of course. Now then, the general overview for user-managed database recovery, depending upon complete or incomplete scenarios. Complete, we want to bring the database up as near as possible to the point of failure. Essentially, what we're going to do here is, depending upon whether the file is critical or non-critical, to assume that it's a critical file, we assume that the database is closed and perhaps you've just hosed the entire instance. You'll need to start the instance and put the database in mount mode. Do your restore. Use operating system copy commands to restore the affected files. Third, issue the recover command to run media recovery and apply redo to your data files. And then finally, open the database. That's the general workflow. If it's a non-critical data file, we can just take the file offline, restore just the file, recover just the file, and then bring the file online. So you can operate on the entire database or on a data file, depending. Now, incomplete, remember one more time, is point-in-time recovery, where we want to restore to a particular system change number or a particular timestamp. Just by way of definitions, friends, I've used SCN quite a bit. I want to make sure you understand what it is. SCN is essentially the time or the clock used by Oracle Database. It's going to be an increasing number that denotes the current state of a database at a particular time. So the idea with consistency, if we do a shutdown normal. We want to make sure that the last SCN in each data file header matches the SCN in the control file. Remember, the control file is kind of the brains of the operation. It needs to know the state of every data file in the database. So as long as the control file SCN references match that which is in your data files, you are in a consistent state, and when you start up the next time, Oracle will not attempt any crash recovery and you won't have to do any media recovery on your own. Now, if you have a failure and a file just goes offline, well, there you're going to have a discrepancy. If you do a shutdown abort and you have data files with an SCN that may be a few ticks ahead of what's in the control file, then you've got a clear case of inconsistent shutdown, and Oracle's going to try to reconcile or bring the data file up to date to match what's in the control file, or vice versa, depending upon what's going on. So you see that SCN is actually a pretty important marker that Oracle uses. Now, we have several ways as DBAs to figure out SCNs. We can query dynamic performance views and use other Oracle tools to get that. I found in my experience, rather than monkey with SCNs, using specific timestamps is a better way to force recovery up to a particular time, simply because I, as a human being, function not according to SCNs most of the time, but according to discrete clock time in my world. But we can do either in our point-in-time recovery. The general workflow for that is we'll mount the database, do a startup mount, restore any data files, restore the control file if that's necessary, and then when we use our recover statement, we use a clause called until, and that until supports either a discrete SCN, if we know what that is, a discrete date timestamp, and there's actually a third option called cancel, until cancel, where we can roll forward redo until we, sitting at the switch, hit the cancel key on our keyboards. Kind of cool, huh? When we finish our recovery, when we're satisfied we've recovered the database up to the point at which we have specified, we then open the database with reset logs, which is going to kind of reset wipe the slate clean, so to speak, and reset the database with new SCN stream as a new incarnation. Now, let's get to that demo. Welcome to our demo on user-managed recovery. We're going to start here by looking at recovering from a damaged or missing control file, multiplexed control file. Now, this is something that has to be done offline. You can't do a hot replacement of a control file, unfortunately. First, on my system, as you see from the SQL prompt, I am logged into SQL Plus as sysdba. I'm going to run show parameter control files to get a run of the current initialization parameters that pertain to my control files. And we see that on my system, which is really perfectly stock, I haven't customized it at all, I have a control file called control01.ctl in my Oradata ORCL folder, and I also have a control02 in my flash recovery area. Now, these are just the default locations, very bad for many reasons. That is, both of them are on my D drive, which is my Oracle base and Oracle home. Number two, the files exist on the same disk. We'll put that aside for now. And what we're going to do is simulate a crash and simulate damage to the control file. I'm going to crash the database, in a sense, by running shutdown abort. Abort is definitely a last-ditch way to shut down an Oracle instance because we're not committing any changes. I'm now going to come into my Oradata ORCL folder. There's my control01CTL. I'm going to move that guy out of its designated location and put it on another disk. I'll put it on my E drive in UM2. So now if we come back into our SQL Plus session, let's issue startup and see what happens. We see an Aura 205 error in identifying control file, check alert log for more info. So essentially we've stopped in no mount mode. Now what we could do is move the file back to its original location. Presumably we have a good backup of the control file that we can put back. Or alternatively, we can simply edit our parameter file. That is to say, we can from our SQL Plus SQL prompt run an alter system set, and we'll just do a control files and manually set that parameter to EUM2, and what was the name of that file? Just want to make sure I get it correct. Control01.ctl, and I'm going to scope that to the SP file. We'll do a startup force. Looks like the control file was accepted. Database is mounted. Keep your fingers crossed now. Database opened. Good deal. So now we can run a show parameter control files and verify that our control files parameter does point to a valid file. Excellent. Next on our user-managed recovery demo is recovering from the loss of an online redo log file. Now, assuming you've set up your Oracle database properly, you have multiple redo log file groups, and just as importantly, if not more importantly, you have multiple members per group. So if you lose a member, as long as those members are on different disks, you should be able to tolerate that. You'll see alert log messages, but the database will continue to clunk along just fine. Now, if you can deal with the downtime, you can bring the database down and copy another group member over the damaged one and overwrite and rename. But note that we can recover from an online redo log file failure online, and that's what I'm going to show you right now. The first step is to gather the necessary metadata. I'm going to do this through Oracle Enterprise Manager. On the server page under storage, again, we can come down to redo log groups, and we can see at a glance here I have 3 groups, and I do have them fully multiplexed. I have 2 members of each group, and you see it looks like 2 have been archived, 1 hasn't. You can always run some log switches just to force that archiving to take place. Alrighty, so what we'll do now is switch on over to SQL Plus, and I'll run a shutdown immediate to bring down the database, and we're going to simulate failure here by opening up the location of those log files, which we can get through SQL Plus. I mean, in addition to Oracle Enterprise Manager, we could have run a query against the dynamic performance view $log file. In particular, we want to select the columns group number, status, and member to give us the group IDs, the status of each member, and then the full file spec of each log file. So I have that just by default. It's under your Oracle base Oradata ORCL folder. And I'm just going to pick on redo log group 1, redo01.log. I'm going to delete this, send it to the old recycle bin, and then coming back to SQL Plus, let's issue startup and see what happens. Well, because group 1 has at least 1 member, we were able to mount and open the database just fine. However, let's simulate some user activity by running some log switches. Alter system switch log file is the command. That's going to shuffle us from group to group. I'll do that a few times. Now note when I hit the third one, there was a little bit of a pause there. I wonder what that could mean, huh? Well, let's quickly run a query. We'll run the select group number, status, and member from $log file, and we're going to order by columns 1 and 3. Let me try that again. My syntax was a little off. Group number, status, member from $log file, order by 1, 3. That was my mistake. We immediately see a reference. I'm going to have to do column format to make this easier to read. But what I want to draw your attention to is the status column for group 1, file 1 is showing invalid. Everything else is null, which is the normal way that we want to see those. Let's go back into Oracle Enterprise Manager. We'll have to re-authenticate. I'm going to come in using my sys credential with sys DBA privilege, of course, and we're going to view our redo log groups. We need group 1 to be inactive to do anything, so I'm going to select it and do a log file switch. And the way we're going to reset this is select the problematic group number and choose clear log file from the actions list. We'll force another log switch, and let's come back and rerun that query, and that invalid status is now clear. Our next stop on this trolley ride through user-managed recovery in Oracle Database 11G is simulating the loss of a non-critical data file. Remember, the big difference here is a non-critical data file, we can keep the rest of the database online and simply take the relevant data file offline while we swap it in. Okay? Now, what I've done in the background is I've created a table on my users table space, just so we have something there. I'm going to simulate failure in that data file by corrupting it. I'm going to go into my location where my data file is, and I'm going to open it up in Windows Notepad. On Unix, Linux, or Mac OS X, you could use the VI editor, for instance. And what we're going to do, it's surprising that in Windows we can actually open the data file like this. I'm going to corrupt it by deleting a few lines from the beginning of the file and then saving changes. Once you've corrupted the file, we can now go back into SQL Plus and try to query a table that exists on that table space. When we try to select from that table, I'm getting errors. You could get a number of different ORA errors here. You could get a 1578, a data block corrupted error. You could get a 1110 error that points to the file that has the problems. Bottom line is we've kind of hosed up our users 01dbf, and the idea is how do we bring that non-critical data file back? Well, what we can do is come back to SQL Plus. I'll clear the screen, and we'll put that data file offline with alter database data file. We'll have to get the path right to the source file, won't we? Let me verify that. CApp administrator or DApp administrator or data ORCL, and the file is user01.dbf. Offline is how we would complete that. Now that we have the file offline in a user-managed scenario, the idea is we can take a known good backup of that file, which you'll recall we created earlier in this nugget in our consistent whole DB backup location, and we can just overwrite. I'm going to nuke the file in its original location, right drag the backup copy over. Now again, you can use CP or OCopy or XCopy, whatever you want. I just find it pretty easy to drag and drop because I can eyeball the file names and the paths very, very easily in a graphical environment. Now that we've swapped the file, we need to recover that data file, don't we? So what we'll do is recover data file and then path it out again, and it's prompting us to specify a log. If you say auto, then it's going to go into the default location of our redo log stream, which we've seen earlier in this nugget. On my system, it's in the flash recovery area, and it's rolling forward the data to restore and bring the file up to a consistent state. Media recovery complete. That's what we want to see. Now, we're not yet finished, of course. We've got to bring the data file online. So let me arrow up because I have the path in my buffer already. I'm just going to get rid of offline and change that last statement to online. Database altered. So we're cool, and we can now continue to operate on that table space. Good deal. Now, to finish out the recovery, the complete recovery in Oracle Database 11g, we need to discuss recovering a critical data file. This is assuming, just like our non-critical restore situation, that we are in archive log mode. And we know that a critical data file is a data file that's in the system table space and any objects that are in the current undo table space. Okay, so if there's any damage there, the database is going to go down. So the recovery technique for that, let me do a shutdown immediate, is to mount the database. So we'll need startup mount for that case. I'll do that right now. And once we're in mount mode, we'll want to restore and recover the file in question. Now, in a user-managed scenario, that's going to involve, again, to repeat for like the 50th time, your operating system commands, where you pluck known good backups of your appropriate files, your critical files, your system table space files, into their target location, and then you issue the recover statement. We learned how to recover an individual file earlier. You may have a situation where you need to recover the entire database. If you've had damage that's going to affect most of your data files, or should I say you have damage that has affected a large number of your data files, then you'll want to restore those files, plural, and then issue recover database. That's going to issue recover against the entire database, and it's going to use the redo log stream to roll forward changes in parallel. And it's going to prompt for your archive log files as it needs them. Remember those options. By contrast, if we want to do user-managed incomplete recovery, our steps are as follows. We're going to do a startup mount, which we've just done. We'll restore any data files using operating system commands. Then we'll recover the database to a certain point and then open the database with reset logs. Now, how do you recover the database until a certain point? All you do is recover database until, and then you specify either a specific change number if you have an SCN, until time if you have a discrete time and date stamp, and the time format here is very sensitive. You have to use Oracle's pre-described date and time format, which looks like this: year dash month dash day and then time. So let's say 14 o'clock is 2 p.m. 2 o'clock p.m., isn't it? So this instructs the database to be recovered up to the state it was on March 16th, 2012 at 2 p.m. The third option is to recover the database until you cancel. All right. And then finally, once you've finished that recovery, to open the database as a new incarnation, you do alter database, open, reset logs. And if you haven't done an incomplete database recovery already, we get an ORA 1139 error that tells us as such. Reset logs option is only valid after an incomplete database recovery. User managed backup and recovery review. In this nugget, we looked at one of the two supported methods in Oracle for performing disaster recovery. In the next nugget, we're going to delve more again into the server-managed scenario in which we use the nifty RMAN tool. And as I promised at the beginning of this nugget, you're probably wiping your brow saying, boy, am I glad that I have RMAN. It makes things so much easier, at least on the backup side. Well, recovery with RMAN is just as easy. I'll let the cat out of the bag and give you the good news now. That having been said, you now know a whole bunch of new terminology related to user-managed backups and user-managed recovery. Most importantly, I'll say, you understand the skills and know how to actually do these things. For instance, performing complete and incomplete database restorations and recovering from various losses like the control file or the redo log file group. I hope that this has been informative for you, and I'd like to thank you for viewing.